Hey, well, good morning, everybody. Good morning, good afternoon, good evening, depending upon what part of the globe that you're on. Well, we're at second draft meeting. This is the second week, and it's Monday. And I thought we would just do a couple things today. I finally got my SKM up and running, so I can share that. Let me close this. Steve, good morning, sir. Good to see you online. Hey, Felix Sandoval, we survived the weekend, buddy. It was we got out of the Sunday. We had a free day Sunday, so Sunday we got down to the where did we go? We got to Venice Beach, but there was another beach before that. So we just took an Uber down and got out of the hotel and got away from everything, and at least got out and about. So that was a good thing. Now this week is 70 next. Let me see if I can do this. I think I can. And I believe if I do me plus PC, there we go. So here's where we're at. Next edition, if you want to know what is going on, you scroll down. See, all of this is first draft meetings. We're going to scroll down to, let me do this. Rather than you watching all of that, I'm going to scroll down to second draft meeting notices. And I am new scene, me plus PC. There we go. Clicked on something there. Can't remember what it was. Here we go. So we are Monday, the 21st. So it looks like panel 5 is meeting, panel 13, panel 7, 9, and 16. Wow, there's a lot of groups going on. The ones I find interesting, panel 5. I want to sit in panel 5, and I want to definitely sit in panel 7. There are some some items in panel 7. I got to take a look at their public inputs or public comments. But panel 7 should be good. Panel 7 is your marinas, your RV parks, and things like that. Panel 5 is grounding and bonding. Panel 13 is your Article 700, 701, 702, 708. Generators, 445, I believe, is panel 13 as well. Panel 9 is medium voltage. So I know we have Eaton has Lou Grayhor. And I think Joe Shoemaker, on that one. So we have a lot going on. There is a lot of changes that will be being considered. If I'm not mistaken, second draft meeting agenda. So if I go to panel, there's one item on panel 5 I'm interested in. It's a public comment on 250.4, I believe it is. And if I go to next, I'm in next edition. I believe it's 250.4. And what they're doing there's a desire to view public comments online. And it's probably going to make me log in, and I have to remember my password. There it is. Oh, it remembered it for me. Nope, my password is incorrect. So wrong password. Let's see if that one works. So in 250.4 is an area that I am interested in looking and seeing what's happening there, because the submitter was seeking to ensure that during a ground fault, that the overcurrent device tripped in the instantaneous region. I didn't like that password. I don't know why. Try that one. So it did. No, it didn't. What the heck? Watch, I'm going to get locked out. So the, no, I'm in. All right. So the submitter wanted to make sure that the circuit breaker tripped in the instantaneous region or the short time delay region. And that's problematic because if the ground fault currents have to trip in instantaneous or short time delay and not in the long time, how are you going to do selective coordination? There's a lot of different issues. It's in 250.4A5. And also the submitter says the overcurrent device shall open within the instantaneous rating, and instantaneous is not a rating, of a fuse, and there is no instantaneous on a fuse, so that's problematic. Or a molded case circuit breaker, or the short time delay rating of an adjustable trip device to eliminate voltage on the faulted conductor in the least amount of time possible within the design parameters of the system. So that's that's an issue. There's no way you could meet that language and achieve other goals within a power distribution system. The 250.4A5 effective ground fault current path just says in A, paren A, opening overcurrent protected device, the electrical equipment and wiring and other electrically conductive material likely to become energized shall be installed such that a low impedance circuit is created facilitating the operation of the overcurrent device or ground detector or impedance grounded system for impedance grounded systems. That's just ain't gonna have that's just problematic. That language there is fine. Adding that last sentence is problematic. So I'm curious. And since it's in 250.4, I'm hoping that they hit 250 and go in order. But time will tell. Time will tell. So anyway, I did get my SKM software up and running on my computer, and I was going to draw and do, remember we did the 75 kVA transformer impedance by hand, and we did the 500 kVA transformer impedance by hand. I would like to do the same thing, but for, how do I zoom? Oh, right here. So I'd like to draw a system. Now, where's the hand? I should have a hand in here, or do I have to use both fingers? Boy, it's been a while since I played in this software. So anyway, so I'm going to put a utility. This is what I'm going to do. So what I want to do, I want to take that system, 500 kVA and a 75 kVA transformer. I want to draw the diagram in SKM, run a fault current study, compare that to the numbers that we calculated by hand, then select the primary and secondary overcurrent devices, and then run an arc flash analysis and compare that with what we got during our session in the past. So that's sort of what I'm looking at doing, and what I have to do is, what I really have to do is fix my Stream Deck so that I can me and clean. Let's do me and iPad. I'm going to do a Control C. Nope. Yeah, Control C. And then I'm going to do a Control V. Oh, Control C, Control V. How do I move this? And I'm going to say me and PC. And I'm going to select me plus PC. There we go. All right. I had to do that because I'm tired of looking at this thing over here. So, cats and jammers, let's do this. I am going to put a utility feed in. I think I'll draw a bus. And I will connect the utility feed to the bus. And then I am going to put a circuit breaker right there. Then we said we're just going to drop all these in, and then we'll put the data in. We'll put the conductor in. Oop. All right, there's our, whoa. Here is our conductor. There it is. We have our conductor, and then remember we were going to a transformer. Boom. I don't know how, I gotta scroll down this way. Whoa. We put a transformer in, and then we had a conductor on the secondary. And then we had a circuit breaker. There's my circuit breaker. Then, whoa, gotta drop it. There it is, I dropped it. And then we had the circuit breaker was connected to a panel board bus, right? So let's draw that in. There's my panel board, and then I connect that. All right, so there's my one-line diagram. And I thought there was a hand up here that I could just drag, and I don't know how to do that anymore. So let's do this. We said the utility, the three-phase contribution, I hope you guys can and gals can see this, will be in amps. And we said 50,000 amps. I'm going to get my notability up. I'm going to bring up the thing. So we'll do the 500 kVA transformer. We said 20,000 amps. Where's my math? Here we go. 500 kVA. So we had X to R ratio was 6. Whoa. We said our X to R ratio was 6, Felix. There's my X to R. I'm going to put the number 6 in there. Number 6 in there. My account needs attention. All right, so I've got a 1 per unit voltage. I've got a fault. There we go. Let's close that window. How do I close it? There it is. Close. All right, so the utility is defined, and we'll call this 50 kA. Now I'm using a utility configuration, but what I'm doing is simply providing a fault current source, whether that be a utility, whatever it is. So I have an X to R ratio, that's all I need, right? All right. So then I come down, and I'm going to put the transformer data in. I'm going to put a nominal kVA of 500. Full load kVA is 500. Primary voltage we said was 480. Secondary voltage we said was 208. And the bus voltage will be 480. And the line-to-line bus voltage will be 208. 208. And then I think, oh, impedance. Impedance. Transformer impedance will be right here. I'm going to do a percent Z and an X to R. And remember, we did a 5.4% Z And I gotta look and see what the X to R ratio. Did we put an X to R in for the transformer? Source, conductor 1, transformer 1, we said the X to R ratio was 4. So I'm gonna put 4 and hit OK. And actually, I'm going to go back to this, and we said it was 5.4 plus 10%, so it was 5.94. There we go. Dry type. Okay. There we go. So now we have a impedance for the transformer. We have the transformer configured. All right, so we have the transformer configured. Now we're going to pick a cable. And we said that the line side conductor was conductor 1. We said, I'm going to go to the library. And it's a delta, so we're going to go to the library. And we are going to pick low voltage. I like to pick, there's a IEEE, there it is, IEEE Red Book. We're going to pick 3 single conductors plus a ground in magnetic conduit. The cable size we said was 500 MCM. And we said there were 2 conductors per phase. And the length was 125 footsies, 125 feet. All right, so we have our conductor, and this will be cable, this will be C1, shift C1. There we go. Now we close. So we have our conductor 1 defined, we have our source impedance defined, and now secondary conductor. And if you recall, for the secondary conductor, I'm going to pick the same. Whoop, no, I can't pick that one. I have to pick 4 because it's a delta Y ground. 4 single conductors plus ground. Please enter number of between 0.1. All right, so there. Now cable size, we said was also 500 MCM. We said that we had 6 in parallel. And we said the length was 10 feet. All right, and we will call this shift C and the number 2. All right, we are golden. Close that. Oh, you know what? Impedance. Let's go to the impedance. We are going to do this. Let's take a look at what we had for a resistance. For conductor 1, this is ohms per 1,000 foot. Ohms per 1,000 foot. Conductor 1 was 0.01208. No. Source, that's the source. Conductor 1 was 0.029 plus J 0.048. It's close enough for hand grenades and horseshoes. They have 0.0294 and X 0.0466. So, I don't really care. And I'm reading that right here. That's your R and X in ohms per 1,000 foot. So I'm good with that. I'll just leave the impedance values. They're a little different, so we know we're not going to get exactly the same numbers. If I wanted to use the exact numbers, 0.029 and 0.048, I would go in and edit that library and edit that conductor. You know what? Let's do that. I can't remember how to do that, though. I linked the library. Oh, I'm going to uncheck that. And then I'm going to go to impedance. There it is. Okay, so my resistance was 0.029, 0.029, and my X is 0.048. 0.048. right. I'm going to leave the zero sequence the same way, and that's it. All right. I'm going to close that. I'm going to come back up to the line side. I'm going to double click on that. I'm going to unlink from library. I'm going to come over to the impedance, and I'm going to type in, because they're both 500, I'm going to type in, I hope I'm hitting the decimal and not a comma. Yep, 0.029. And the X is 0.048, 0.048. And then I close. All right, so I have defined the source. I defined the, primary and secondary conductors. And I'm going to run the fault current. So I'm going to go run, balance system studies, short circuit. I am going to run the ANSI, because we used ANSI rules of thumb the whole bit. And I'm going to hit run. 0 errors, 0 warnings. And it says it's saved. Where's it at? PTW13 projects TES. So if I come here to my folders, C, PTW, projects, and I go down to TES because I forgot to put the T at the end. All right, there should be a PDF in here. Date modified. Input report. Test project. What's it called? sc.rpt. sc.rpt. There it is. Always. Uh-oh. Uh-oh. SpaghettiOs. More apps. I'm going to open it in a notepad. There we go. Notepad will do. All right, so now remember, close. I have bus, I have bus 4 for the available fault current. And then I have, that's it. That's the only bus. So I should have, I'm looking for bus 4. Bus 4 fault current is right here, 17,412. And I am going to 500 kVA base values, 208. I'm looking for my fault current. I per unit. When given I short circuit, that's the utility. Where's my fault current? That's the arcing current. There it is. Ha 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 ha. All right, so you know what I should do? Do I have enough? Yeah. Let me unplug my phone. And I'm going to plug this in. Plug that in. We're getting very sophisticated. Me and iPad. Is this going to work? Yes. All right, so remember our calculation. We had, there's our short circuit, 17,402. And our calculation from this was 17,412. So this is pretty doggone close, right? 17,412 as opposed to 17,402 amps. So now that we know that, so I got a little bit higher. I got 10. So it's 17,412. I got 10 more amps. So 10 more amps using the SKM software as opposed to my hand calculation. So now So now what I got to do, and this is going to be the fun part. Now I've got to pick the circuit breakers. So we know we had, so now we know our numbers look good. What was the circuit breaker? It's 800 amp. So we have to pick an 800 amp breaker at the top. So if we go to library and we pick, now remember, this is the only way to get SKM to correctly work. You have to do this. When you want to add an overcurrent device, like say a circuit breaker in this example, you have to go to the manufacturer and select Eaton, Cutler, Hammer. None of those other stuff work. Okay, only Eaton, Cutler, Hammer. I don't know why you would choose anything else. So nope, wrong ones. Oh, I don't want a motor circuit protector. I want a low voltage breaker, and let's use a thermal mag. Let's see if we can get a thermal mag. See, you do that, then you come over here to Cutler, Hammer, or Eaton. Let's this library has a lot of our Cutler, Hammer stuff in it. So let's do I need 800 amps. 800 amperunos. So what I'm looking is in the description, I'm looking for something that goes to 800. That one does, but I don't like that one. Let's find a Eaton. Let's go to Eaton. And we're looking for an 800 amp molded case circuit breaker. There, well, here we go. There's a PD4. Well, let's try that, a PD4. All right, so I selected the PD4. And I am going to change this to 800 amps. I'm in a 208. That's 500, 600, 700, 800 amps. The available fault current was what? I'm on the primary, it's 50,000 amps. So I'm going to use the PD whatever, 4. There we go, 800 amps. Thermal curve, instantaneous. I'll leave it there, and I'm going to do this, close that. So now what I'm going to do is I'm going to select this breaker, and I'm going to hold the shift key down. I'm going to select that transformer, or maybe it's control, right mouse click, and say go to TCC drawing. We're going to call this 500 kVA, option 1. And hit new. There we go. All right, so now what you'll notice is that everything is way over there to the right. So what we can do, this is current times 1. I can go to TCC settings and do increase that, so that's current times 10. So all of this, if that says 100, it's 100 times 10. If that's 10, that's 10 times 10. If this is 1, it's 1 times 10. So all of these are multiples of 10. So now you got your transformer inrush. Now this is the primary breaker. If my inrush current is to the right of the instantaneous, it's going to trip. This breaker does not look wunderbar. I'm going to try to change this breaker. Let's go back to device, library. Let's pick, that's IEC. Whenever you see IEC, that's an international standards. Whoa. Library. I need a breaker. So what I'm going to do is I'm going to put an electronic trip unit. So I'm going to go to static trip. Go into static trip, and you always have to pick Eaton. Remember, that's that's the only way that'll work correctly. Here's an 800. That's a GN. I don't like that. 800. Here we go. LS. It's a fixed instantaneous. It's an M frame. Can't get an L frame, so let's do an M frame. Woo doggy. So this curve here looks crazy, doesn't it? Instantaneous is fixed. Short time delay, I'm going to turn that all the way up to 7. Turn that all the way up to 20. I'm at 800, so I can't get that. This is a primary breaker, so I need to fix that. Let's go to an NG. All right, we go to an NG. Let's close that. Instantaneous 12. Oh, look at that. Did you see that? Did you see that move? That was a nice little move. Now I have to do the delay. Short time delay. I'm going to move this up. There it is. Whoa. Move it up. There we go. Now I'm riding through inrush. Riding on empty. All right. So then I can move this up this way to... when we run our arc flash study, we'll run it with... That may help incident energy on the primary. All right, so there we go. So we have an 800 amp. Is it 800 amp? That's 1200 amp. Oh boy. I got to lower that. 800 amp. 100, 200. Let's bring this down. All right, so this is 100, 200, 300, 400, 500, 600, 700, 800. That's 811 amps. All right, I'm good. What if I move this to B? What if I move this to D? All right, so I'm gonna leave this on B, on C, I think. Yep, there we go. So that looks good. That's on my 800 line. All right, so that's my primary breaker. Now let's pick the secondary breaker. Now I am going to slide down to the secondary breaker, which we said was what, Tom? We said the secondary breaker was a 2000 amp circuit breaker. All right? Okay, 2000 amps. So now we go to library. 2000 amp breaker, we are low voltage breakers, static trip. And look, it automatically goes to Eaton. Scroll down to 2000 amps. RG frame. Long time, short time. $2,000 amp. Long time, short time, instantaneous. LSI is long time, short time, instantaneous. We're going to pick that. So now we have, I'm going to do a run. Data block. Oh, I used to have my own data block here. And I don't have it anymore because it's on my old computer. Oh, crud. All right, close. All right, so let's go back to the TCC. Let's go back to the time current curve. Let's pick this. We are going to add a device. We're going to add an existing device, which is PD2. Remember that. I hit OK. There is my downstream. Now, it doesn't matter if they overlap because the primary and secondary, they take out the exact same load, so that doesn't matter. I'm going to leave this. That's a 2000 amp. That's 2000 amp. I'm going to leave everything at default. That's all the lowest settings. All right. So now, what did I get? When I estimated, now I didn't pick the same breakers, but I estimated what did I estimate the calories to be? I didn't write them down. It was high. I'll have to go back and look at the video. But because remember, we went up to online and we just picked a breaker and reflected the currents and stuff like that, but I never wrote the energy. So now what I'm going to do is I am going to run. I'm going to run the system studies again just for giggles. Run. There we go. Close. Now I'm going to run my arc flash evaluation. Now, okay, so I've got to pick some stuff here. I am going to pick, here's what I'm going to, bus plus PD line side. What that'll give me is two numbers for arc flash on the secondary. One based upon the main overcurrent device. Ooh, and the second based upon the upstream. But I got to do something else. Hold on. I'm going to hit cancel. Here's what I forgot to do. I am going to come down here to this bus. I'm going to double click on it. Now I have to equipment library. You're going to have this would be a power line 4. I'm going to do this. See this? I'm going to pick that, double click, and what it's going to do is put in all of the information regarding what I need for voltages and all that. If I go to arc flash, I'm going to do a VCB, and look, it has the box height, width, depth, bus bar gap, and working distance. All right, so that is needed for a good arc flash calculation. So now I'm going to go run my arc flash evaluation. What time is it? 7:30. I got to get downstairs. Okay, so bus, I'm going to do PD, bus plus PD, line side. Line and load sides, calculations. And then I'm going, that's report options, fault currents. I'm using the 1584 2018 report options, and I'm going to hit OK. There she blows, Cupcake Island. So for panel 4, based on line side, for line side propagation, our calories are 33.3. You see that? Where's it at? Right there. 33.3 right there. So that's our calories per centimeter squared. And that's because of the protecting overcurrent device is not on the secondary, it's on the primary. So, we got VCBB. So here's the next thing I'm going to do. I am going to come in to, I think it's document. Nope. You know what I'm looking for is promote to scenario. Scenario manager. Okay, we're going to scenario. That's the base project. We're going to clone it. And we're going to say yes. Now we're in scenario 1. Activate and exit. All right, so now we're in scenario 1. I'm going to go back to the one-line diagram, and here is what we're going to do. We're going to come down here on the secondary. We are going to double click on this, and we're going to go to the secondary connection, and we're going to disconnect. Hit close. Hit close. So now what we're going to do is we're going to roll this down, and we're going to add a conductor. Actually, can I copy this? Clone. Boom, I did. I cloned that conductor, so I have the exact same conductor on this, and I am going to add 10 feet of that puppy right here. So now what I've done is bus 5, there's my 10 foot. So now bus 5 basically we popped out that circuit breaker, it's on the secondary, into its own enclosure. And now the incident energy at bus 4 is going to be determined by the clearing time of the secondary overcurrent device, not the primary overcurrent device. And I'm hoping this runs, so let me do a run, Forrest, run. And I'm going to hit run the fault current study first. No warnings, no nothing there. All right, so now I'm going to run my arc flash evaluation. All of the same settings. I hit OK, and bus 4 is now bus 4 incident energy is 0.95. Tell me that is not sweet. So my incident energy went from 33 something to 0.95, and all we did was move that 2000 amp breaker into its own disconnect, feeding a main lug only switchboard or panel board. In this case, it was a panel board power line 4, 2000 amp. So that's all we did. All right, so we did a couple things just now. We verified our calculation that we did by hand. Okay, remember this calculation. We verified this calculation. We got the same fault current. Oh, wait a second. There's my calculated arcing currents based upon 17.152. I had 7.152 calories. I can't remember. Hey, good morning, Alan. Good to see you, buddy. So what we just did, Alan, was we verified our calculation. What is it? Let me scroll up. We did this. We verified that number. We modeled the 500 kVA transformer, 800 amp. We selected an overcurrent device on the primary. We selected the secondary overcurrent device, and what we did in the second scenario was this. Copy this. Hit copy. All the way down to the bottom and hit paste. So what we did, Alan, on the secondary was this. Trying to figure out what I want to do. We did this for the secondary. We moved this down. I'll draw it this way. Nope. That's still a secondary conductor. Yeah, there's what we did. Conductor 2, and then we added a conductor 3 right there, and we put this puppy in its own enclosure. So we basically, and then we got rid of this puppy here. That's what we did. Moved the PDP main out of the PDP enclosure and maybe into the transfer. Oh yeah, you know what? That's a good point. You could move that breaker into the transformer itself, but that's what I did, was just move it, just get it out of there, because the important thing is it's somewhere on the secondary of the transformer, but not in that enclosure. And it's amazing how much of a difference that was. This now protects the entire, yeah, that's exactly right. Much better. So as long as we can pop that out, then you know what, Alan, the challenge then is, what's the price? And do I have the space? to your point, if I bring that into the transformer, then I don't have to necessarily worry about space. I should be able to reduce the price of that panel board, that 2008 panel board, because I don't have a main. It's a main lug only panel board. But you need space and you need price, right? So, and then what we'll do, and I'll do this later, I got to go downstairs now for the code panel meetings, but we will take a look at that 75 kVA transformer. And then maybe even on this one here, I'll put an arc reduction maintenance switch on the primary breaker and see if that fixes it. I think the breaker that I selected on the primary, that 800 amp breaker, did have an arc reduction maintenance switch on it. So I can change the trip curves and see what that does. But I finally got my SKM back up and running, so that's a good thing. It's on this computer now. You know what I don't have, Alan? Hey, Felix. Eden will always work nice and easy hand calculations or SKM. Absolutely, it does. I tell you what, I'm happy that the fault current came out within 10 amps, so that's a good thing. But you'll notice what I did. I changed the conductor. The conductor impedance that is in the library is slightly different than the conductor impedance that I used from the table 9. Now the question is, what is the right impedance to use for those conductors? That's the challenge. But that's that's what we'll do. So we'll take a look at the 75 kVA transformer. Maybe later on today. I don't know. By the time we get out of the meetings down there, I'm pooped. I am out. My brain is fried, trying to get everything done at the same time. But today I'm not on the code panel, so I will be monitoring. I'm going to hit panel 5 and probably drop into panel 7 as well. So, and I'll give you a report on that probably this evening. I'll give you a report, or maybe tomorrow morning. Maybe I'll get up tomorrow morning. I had a 5 o'clock in the morning, 5 a.m. call this morning, so I was up at 4. I went to bed early though. I left the guys downstairs. I said, I am going to bed early. I was exhausted. But yep, that's what we're doing this week. So panel 10 starts Thursday, Friday, and Saturday. So panel 10 starts Thursday. We finish up on Saturday, and I leave on Sunday. All right, everybody. Oh, what's this? I see another long one. If those labeling changes get made in 110 for arc energy, there will be a ton of people wanting to learn these calculations and wanting to run them on a computer program such as you're doing, Steve. Yeah, I'll tell you, it's not hard. It's not hard to do. Print those labels and get them out there. Felix, thank you. Thank you very much. And we got some per unit, so all you people out there who are trying to get your PE license, all that stuff is very helpful for the PE exam. And the more we understand what's going on behind the scenes in those software applications, the more depth of knowledge that we have, the better we are when we are looking at that information and wondering, does it pass the smell test? All right, I am going to pack my bags here, get downstairs, find out where panel 5 is, and get cooking. I'll let you all know how it goes. Take care. Stay safe. Thank you, Steve. Thanks, Felix. And thank you, Alan, for joining in. And anybody else who's watching this who wants to remain silent. Catch you later. Take care. Stay safe. And please stay healthy. Take care.